Hi everyone. In this video, we'll cover topic related to types of functions. We'll cover multiple types of functions such as into, onto, bijective, many to one-to-one. And we also will go through an important topic which is related to composite function and all the examples related to composite functions. There are multiple types of functions. So first one is into function. What is into function? Now you look at this particular diagram, right? There is one element in set B which is not mapped to any element in set A. This is left out. No pre-image. That is pre-image. These are pre-images and these are images. There is one element for which there is no pre-image or there is no mapping to any element in set A. So that's why this becomes an into function. Function from A to B is an into. This function f from A to B, you'll have to write it like this. Function from A to B is into here. The next type of function is many to one function. In the name itself, there is a clue. Many elements in set A are mapped to one element in set B. For example, if you see -1 is mapped to 1, 2 is also mapped to 1. Here 1 is mapped to 4 and -2 is also mapped to 4. So multiple elements from set A are mapped to same element in set B. So this becomes many to one. That is same image. 1 is the image for -1. 1 is the image for 2. 4 is the image for 1 and 4 is also the image for -2. Third type of function is one-to-one function. Again, the name itself indicates one-to-one. For every element of A, set A, there is a unique image in set B. That is unique and different. For 1 you have P, for 2 you have Q, for 3 you have R. So it's one-to-one. One element here mapped to one element here. One element mapped to another element. It is opposite of this many to one. It's exactly opposite of many to one. You have two elements here mapped to one element. But in this case, in one to one element mapped to one element only. So we write f of 1 is P. F of 2, that is element 2 is mapped to Q. So f of 2 is Q and f of 3 is R. Onto function. Onto function is also called a subjective mapping. Now if you see both of this 1 and onto look similar. Small difference. Onto means every element in set B should have a mapping to some element in set A. It should have a mapping, right? Basically, all of these elements should become the images for elements in set A. So you saw in the first type, right? Let's go to the first type. In this first type, 25 was left out from set B. But in onto, every element should have a mapping. So this is exactly opposite. Into and onto are opposite, right? In into, you'll have one element, at least one element not having any mapping. In onto, every element should have a mapping. Remember, onto, into. These are opposite in nature. Many to one, and one to one. Now, fifth type is bijection or one and onto. Basically, a function which is satisfying both one-to-one function and onto function is called as bijection. So this is one example, one-to-one, because every element in set A is mapped to different element in set B and it's onto. Why is it onto? Every element in set B is having a mapping. So it's both one-to-one and onto function. So in such cases, this is called as a bijection. Now this is one-to-one into, right? This is set, a function is said to be one-to-one into, as the name implies, the function should be both one-to-one and into. Remember what into is? In into function, always at least one element left out in set B. So here one element is left out. So this becomes an into. This is an into. And it is also one-to-one. Why it's one-to-one? Every element in set A is exactly mapped to a different element in B. It is not that you have 1A and 2A. It's not like that. You have 1A, 2B. So every element in set A has a different mapping in set B. So in this function, there is one condition, that is f of x1 is equal to f of x2, which means x1 is equal to x2. So whenever you have such kind of function, you'll have to write f of x1 is equal to f of x2, which is equivalent to x1 being equal to x2. So here you notice range of function is a subset of B. The range, what is range? Range is nothing but it's a set of all images. Here images are A, B, C only. D is not included. This is range. Now if you notice, range is a subset of B, set B. What is B? B is A, B, C, D. So range is subset of this. Now next one is many one onto mapping. This is a function which satisfies two conditions. One is it's a many to one function. You have multiple elements in set A mapped to same element in set B. That's why it's many to one. And why it is onto? Onto means every element in set B should have a mapping. In this case, what is range? In this case, range is 1, 4. What is codomain? Codomain is 1, 4. Now you notice range is same as codomain. Codomain is nothing but set B, right? So range is same as codomain. If you look at the earlier one, if you look at this one, 1 to 1 into mapping, range is a subset. Range is a subset of codomain. Range is a subset of B. Constant function. A constant function is nothing but every element of set A is mapped to single element in set B. So if you see f of 1, that is function of 1 is k, function of 2 is k, function of 3 is k. So all these images are same images. So codomain is set B here, k. Inverse function. Say we have a function defined from A to B. A function from A to B. Function from B to A becomes inverse function. So in this case, if you notice, it's a 1 to 1 function. A is mapped to B, B is mapped to A. So it's 1 to 1. And onto. Onto means every element in set B should have a mapping. So f is the function from A to B and f inverse is function from B to A. Let's take this example. Say you have set A and set B. Set A as 135 and B as PQR. Right? Now there is 1 to 1 mapping from every element in set A to element in set B. And every element in set B is having a mapping. So it's an onto. This is onto and this is 1 to 1. Right? Now, so this is a function from A to B. Now what will function from B to AB? So you have set B here and set A here. Right? Now, this function from B to A is called as inverse function. If any function is 1 to 1 and onto, then it is called as bijective. So both f and f inverse are bijective functions. Let's talk about composite functions. Function within a function. Say I have three sets A, B, C, right? There is a function from set A to set B. There is a function from set B to set C. Let's call function from A to B as f, function from B to C as g, right? And there is a function from A to C also. Directly from A to C there is a function. Now if you see, both of these are related. Both of these are related. How? Here normally what you have? Normally you have say two sets A and B. You have elements A and P. This is a function from A to B. How would you write f of A? How would you write f of A? You would write the mapped. You would write the image, right? F of A is nothing but P because A is mapped to P. A is paired up with P. So f of A is P. Now, since f of A is P, assume that this was P earlier. Assume that it was P earlier. Now, since f of A is equal to P, instead of P, I can write f of A because f of A is P. So I've written f of A. Now, I have another function from B to C. Assume that there was P here and assume that there was Q here. So G of P is Q. This is what we would write normally, right? And here we would write f of A is equal to P. This is how we would normally write. Now, instead of writing P, we have written f of A because f of A is nothing but P. So instead of P, I have written f of A. Instead of P, I have written f of A. So this is going to be, I'll substitute. Instead of P, I'll write f of A. And this is Q. Say, this is Q. Instead of Q, I can write G of f of A. It means the same because both of these are equal. Now, we have two functions f and g. Now, what is this composite function? What is composite function? So, I can write function from A to C. Function from A to C is a composite function. Why? Because function from A to C is having a function from A to B and B to C, right? There is a function in between here. We can call this function as G of f. We can write this G of f of A as G of f. That's it. Just a short form. So if I say G of f, you should always write as G of f of A. And if I say f of g, I should write it as f of g of A. This is how you'll have to write composite functions. The last type of function is identity function, right? This is simple one. You would denote it as IA, right? IA. What is an identity function? Here, the image, this is the image, right? This is the image. Now, every element in A is having a mapping to element in set B. Here, what's happening? The element is same. 1, 1, 2, 2, 3, 3. Element itself is same. So, such kind of a function is called identity function. So, if I write f of 1 is 1, f of 2 is 2, f of 3 is 3. So, here the image is same as the element. Therefore, this is called as an identity function. It's represented as IA. Let's find the eighth problem. This is related to composite function. What is composite function? Function within a function. So there are two functions here. F of x is x, g of x is x cube plus 1. Two functions are there. You have to find f of g of 1. F of g of 1. Let's take the first one. What is f of g of 1? We'll have to first write it as like this. F of g of 1. F of g. F of g. Write it like this. What is g of 1? For that we should know what is g of x. What is g of x? It's x cube plus 1. If g of x is x cube plus 1, what is g of 1? We need g of 1 here. What is g of 1? Instead of x, we'll have to put 1. So it will be 1 cube plus 1, which is 2. Now, instead of g of 1, we'll put 2. So now what do we have? We have f of 2 now. What is f of x? F of x is x. F of x is x. Now we'll have to find f of 2. So instead of x, we'll put 2. Instead of x, we'll put 2. So f of 2 will become 2 itself. So this is the answer. F of g of 1 is 2. Let's go to the second one. F of g of 2. Same steps. Instead of 1, I'll have to put 2. Let's do that. F of g of 2. This is the first step, key step. Remember this. Now, what is g of 2? G of x is x cube plus 1. G of 2 would be, instead of x, I'll put 2. 2 cube plus 1, which is 9. So g of 2 is 9. Now I'll have to find f of 9, right? So f of x is x. So f of 9, instead of x, I'll put 9. So it's 9. So I get 9 as the answer. Let's find the third one. Third one is g of f of 1. G of f of 1. Let's first write the functions. F of x is x. G of x is x cube plus 1. What is g of f? G of f of 1 means g of f of 1. What is f of 1? F of x is equal to x. So we'll have to find f of 1. F of 1, instead of x, I'll put 1. So f of 1 is 1. Now, g of x is x cube plus 1. I have to find g of 1. G of 1, instead of x, I'll put 1. 1 cube plus 1, which is 2. So g of 1 is 2. Now let's go to the fourth one. Fourth one is g of f of minus 1, which is nothing but g of f of minus 1. So g of f of minus 1. F of minus 1. Instead of x, I'll put minus 1. So minus 1. So I'll get minus 1 here. Now I'll have to find g of minus 1. G of x is x cube plus 1. I have to find g of minus 1. So g of minus 1 will be, instead of x, I have to put minus 1. So minus 1 the whole cube plus 1. Minus 1 the whole cube is minus 1 plus 1, which is 0. So this is going to be 0. Now let's take the ninth problem. If f of x is 2x plus 1, g of x is x square plus 2x plus 1, find these two function values. We'll write this as f of g of 2. So what is g of x? G of x is x square plus 2x plus 1. We'll have to find g of 2. G of 2 is, instead of x, I'll put 2. So it will be 2 square plus 2 into 2 plus 1, which is 9. So I'll get f of 9. Now I'll have to find f of 9. For that I need f of x. F of x is 2x plus 1. I have to find f of 9. So f of 9 will be, instead of x, I'll put 9. So 2 into 9 plus 1, which is 19. So this is nothing but 19. Now let's find the second one. Second one is g of f of 3. This is nothing but g of f of 3. Now I'll have to find f of 3. To get f of 3, I need to know f of x. F of x is 2x plus 1. I need f of 3. So f of 3. Instead of x, I put 3. Instead of x, I put 3. So I get 7. So this will become f of 3 is 7. Now I need to find g of 7. To find g of 7, I need to know g of x. What is g of x? X square plus 2x plus 1. This is g of x. I need to find g of 7. That means instead of x, I'll put 7. 7 square plus 2 into 7 plus 1, which is 64. So I'll get 64 as the answer. This is the last sum, 10th sum. If f of x is x square and g of x is x plus 1, find these function values. Find this composite function. Let's find f of g of x. What is f of g of x? F of g of x. Now, we need g of x. What is g of x? G of x is x plus 1. So I will directly write, instead of g of x, I'll put x plus 1. Now I need to find f of x plus 1. To find this, I need to know f of x first. What is f of x? X square. I need to find f of x plus 1. So instead of x, I put x plus 1. Instead of x, I put x plus 1. So it will be x plus 1 the whole square. So this is nothing but x plus 1 the whole square. Let's find the second one. Second one is g of f of x. This is nothing but g of f of x. I have to find f of x. What is f of x? F of x is x square. So instead of f of x, I'm going to substitute x square. G of x square. Now to find g of x square, I need to know g of x. G of x is x plus 1. I need to find g of x square. Instead of x, I put x square. Instead of x, I'll put x square. So x square plus 1. So x square plus 1, this is the answer. So with this video, I've come to the end of this particular chapter, which is related to relations and functions. Thanks for watching. Hope this video was useful.